Okay, for our next part, to continue to talk about interactions, I want to do one more example. And it's inspired by the conversation we had in this room after I turned off the Zoom, which was all about cats. So I'm just going to very briefly walk through an example output from an analysis that I've done. And this is a data set of where cat owners have rated the personalities of their cats. Yes, I'm serious. Here's the data if you would like to play with it or look at it. Cat owners rated their cats on 52 different personality trait items on a 7-point scale. There are published papers on this and everything. The cat owners are either from New Zealand or they're from Australia. So we have cats from New Zealand, we have cats from Australia, and we have personality traits on several 7-point scales. So what I have here is a multiple regression. So I just have multiple predictors in this linear model, predicting how playful a cat is based on how curious the cat is, and whether the cat lives in New Zealand or in Australia. So my outcome variable here, my dependent variable, is how playful the cat is. I have one predictor, which is how curious they are, and one which is, do they live in New Zealand, yes or no? In this case, because there's no 0 indicated here, like we've seen in the other GLM outputs, sometimes we'll see one that has a 0 next to it. We don't have that. So here we're going to rely on New Zealand. 1 is yes, New Zealand, and no is no, it's not New Zealand, it's Australia. So I just walked through within this how to interpret these, which is the same thing as your homework for last week, which is holding constant which country the cat is from. The more curious a cat is, the higher their playfulness rating is, their expected playfulness rating. Or if you're holding curiosity constant, people in New Zealand are rating their cats as more playful than people in Australia, and that's significantly different from 0. Why?
Because New Zealanders have this stereotype of being happy, lovey people.
New Zealanders are just happy, lovey people?
And they have happy, playful cats.
And maybe their cats are happy and playful.
And they have no COVID.
New Zealand has no COVID. These are pre-COVID data, but still, I like that interpretation. That would be great. So I just pulled out all of the components of this regression equation, of this linear equation here to say, if I have, here are my weights, here are my plugging in information about different variables to calculate things out. I just wanted to walk through an example of this. We've done it before, but I don't think I had it in this much detail for you on the slides. So I wanted to walk through it this way. So I know that a low value of curiosity is 1, because the scores are 1 to 7 on all of these items. So a low is 1, so I plug in 1 to get my expected y for when curiosity is 1. Curiosity is low. You can also pick another value and plug it in. So it won't matter, look at this, 0.33 here is the relation between x2, is the weight that you would use to multiply by x2, its relation with y, no matter what you plug in here. If it's 4, if it's 1, if it's 7, it doesn't matter. This term is going to reduce down, but these are going to stay. It doesn't change. Now, if I've added an interaction to the model, which is, does country moderate the relation between curiousness and playfulness, which blows my mind, but yes, somehow it does. Which this is represented by the x here. This x here represents the interaction term. Then this is telling me for cats from Australia, which is what it means when New Zealand is 0, for cats from Australia, the relation between curiosity and playfulness is significantly different from 0. B equals 0.49. And you can interpret the other one the same way. With the equation here, if I've done the same thing for low curiosity being 1, I plug in 1 to this equation. But look, it has to go here, and it has to go here. So when I reduce this, plug and chug, as it were, if I reduce this down, I get y equals 2.97 plus 0.76 times x2. So now I'm going to do it again. 0.76 is the relation between x2 and y when x equals 1. So hold on, now I'm going to do it again. Now I've made x equal to 4. x1 equals 4 here. I've plugged in 4 here. I also have to plug in 4 here. And as I reduce down using algebra, now you'll see that the relation here of x1 with y, of x2 with y, is 0.46. Look at how different that coefficient is. Before, it was 0.76 when curiosity is 1. And when curiosity was 4, it's now 0.46. The slope is different because of where curiosity is, where I am on curiosity. So 0.46 is the relation of x2 with y when x1 equals 4. So I just wanted to walk through how the math sort of plays out to give you those different slopes. So before, we've been talking about slopes really conceptually today mostly, but you have done this math before to get all the way to your predicted y's. But this is just part of the steps to get you part of the way to y. Not all the way to y, just part of the way. So x2 here is the difference between cats from New Zealand and cats from Australia. It's a smaller relationship here when x equals 4 than it was when x equaled 1. Okay. So the next thing that I want to do is I want to do some live analyses for the next little bit of class. So what I've pulled up is the GradPubs data set, which I gave you in week 3 as an example as possible for your homework assignment to use. And I'm going to look at a couple of key variables. These aren't the only ones, but these are a few of them. I have this number of peer-reviewed publications, and I have were you paid to be a research associate. And I'm going to talk about having an interaction with 2 dichotomous predictors and work on some recentering and just sort of show you what these things look like. So, one second, guys. I'm going to share my screen, but I have to get it all pulled up for you. Okay, here I am in this GradPubs subset data set. I said hide. Okay, here I am in this GradPubs data set. And you'll see here we have people, about 5,000 graduate students. And do you remember this? They're from physics. They have this broad field name, physics and mathematical science. We also have engineering, and we have humanities. Those are the 3 that are in this data set. Okay, so because our rows are graduate students, any inferential statistics we make should be we should be able to infer to a population of graduate students. Because we've information on students, so we're talking about students. So I've done some pre-exploring of this data. there are a bunch of satisfaction questions, and they're all scored with 1 being the most satisfied and 3 being the least satisfied, which didn't make a lot of sense. So I've recoded all of those into a satisfaction score. And then here's some information. It's like, how satisfied are you with the quality of your teachers? With the quality of your dissertation advisor? With the quality of your curriculum? So we've got lots of information about program satisfaction. So I created an overall satisfaction mean of 5 of these variables. And let's look at that. So I have about 5,000 people. The minimum is 1. The maximum is 3. Standard deviation is about 0.5. There's also a variable called support. And that's how supported you feel by your program, how supported you feel by your dissertation advisor, how supported you feel by the faculty. So I did the same thing here to get the mean of support.
Dr. Logan, are you recording by any chance?
Yes. I'm just going to make 100% sure I'm recording. Yep. Okay, so we have, again, about 5,000 people with a mean of 3 and a standard deviation of about 0.6. So now, I started to look at some other variables to see what we had here. We have, do you have kids? What's your marital status? What's your gender? There's also some stuff about how many kids you have under specific ages. And then I have these, which are, were you paid to be a teaching assistant and were you paid to be a research assistant? And if I'm thinking about what's going to predict the number of publications someone has, I think being a research assistant is probably pretty high up there. If I'm paid to do science, I'm probably going to have more publications than someone who's paid to do things that aren't science or who's not paid to do science. So the first thing I did here is ask the question, is number of publications predicted by whether you are paid to do research? So let's take a look at that. So unfortunately, these questions are a little bit weird. Were you paid, what was your largest source of financial support during your doctoral program doing research? Yes, I checked the box. No, I did not check the box. So assuming everyone who did not check the box did not have this as their primary source of support, then that's what we'll move forward with here. Here we get the descriptive information for each. So this is the number of refereed articles authored or co-authored by whether they did not receive funding to do research or whether they did receive funding to do research. And you see that if they did receive funding, that's a little bit higher, about 4 publications. And if they didn't, it's about 2. But is that significantly different from 0? Let's look. If we scroll down, we get our test of between subjects effects. I have an R-squared that's pretty small, about 1% of the variance. But I have a significant F-test, so I've significantly reduced the error in my model. If I look at my coefficients box, I can see my intercept here, which is whenever this variable equals 0. So this is people who did not receive funding to do research. They have about 4 publications. Wait, people who did receive funding to do research have about 4 publications, and people who did not, now they have a 0, they are getting about 2 fewer publications. 1.7, 1.8 fewer publications, which is significantly different from 0. Good, just one main effect. That's basically just a simple ANOVA, simple t-test. So now let's do some other stuff. If I want to do the same thing, but I want to control for how supported they feel or how satisfied they are, does anybody have a preference Which would you rather have, satisfied or supported? Nobody wants to pick. I'm picking satisfied. So now I'm going to say is the number of publications predicted by whether you are paid to do research, controlling for satisfaction with the program. Again, this is not really changed. I still have 2 publications if they did not receive funding and about 4 if they did. And here you'll see we get now a coefficient for overall satisfaction. So this is telling us now we're controlling for this variable in this relation. We still see a significant difference between whether they were paid to do this or not. Satisfaction is significantly related to number of publications also, but we still have an effect of the differences between how you were paid. So now I want to look at an interaction. How can we do an interaction here? What would an interaction question be?
Does overall satisfaction and its relationship to publications depend on support?
Yes. On support. That would be one. That I don't have supported in this in this model right now. Right now I have whether you're paid to do research. Can we do one? Let's do that one next. So hold on that one. Can we do another interaction question that has to do with how you're paid to do research? Anybody at home have an idea?
Does the overall satisfaction in the relationship with publication depend on research?
Hold on. Does you broke up a little bit? Does overall satisfaction?
And its relation with its publication depend on whether you are paid to do research?
Yes. I think this is what you said. I sort of paraphrased here. Does overall satisfaction and its relation with number of publications depend on whether you are paid to do research? What do we think? Do we think it's going to depend on that? What do we think it's going to look like? Do you think it's going to cross? Is it going to be a disordinal interaction or an ordinal interaction? What do you think? At low levels of satisfaction, what do we think will happen? Will there be a difference between being paid for research and not paid for research in terms of publications? We'll have fewer publications than those who were, people not paid for research will have fewer publications than those who were paid to do research. What about at high levels of satisfaction?
I would still say they probably have fewer, but the gap would be smaller.
That there'll still be fewer, but maybe not quite as much fewer. I buy that. Because if you're really satisfied, it doesn't really matter if you're paying me to do research or not paying me to do research. I'm still getting a lot of papers out. Whereas people who are very unsatisfied, maybe getting paid for research could potentially make up for that lack of satisfaction, and you're still able to keep putting out papers. Okay, so let's put that in this model, and we do that because this is the same model. And now we do it by, remember, we have to keep our main effects in the model. Otherwise, it's not an interaction, it's just a variable. All right, there we are. We still get our main effects. And now let's move down to our between subjects effects. Our R squared is about the same, 0.18, so about 2% of the variance explained. And let's look here. We have an intercept, which is going to represent people who are paid to do research. And we have an overall satisfaction that's low. So when overall satisfaction is 0, there's a difference between these of not even quite a publication. It's a pretty small gap in between being paid to do research and not being paid to do research. And for people who are paid to do research, satisfaction goes up, number of publications goes up. And let's look at the interaction term. This is not significantly different from 0. Oh, this is also not significantly different from 0. Look at that. So our x1 is what? What's our x1? Satisfaction. And our outcome is what? I forget. Pubs. When satisfaction is 0, there's almost no difference between being paid for research or not. This is going to be paid. This is not paid. There's almost no difference. Negative 0.751, favoring the people who are paid. But even though this is a non-significant interaction, I want to interpret it anyway, that this gap is going to change as we go up. How are we going to find what it would be like when satisfaction is high? How could we find that? There's at least 2 ways we could find that. Who can come up with one? Here's your clue. When satisfaction is 0. Let's write the little linear equation. Let's write it. y equals, what do I put first? $1.62 plus minus 0.751 times, can I call it paid? You know what I mean if I say paid? Should I change it to something else? Huh? A12 is that paid parameter, yes or no, plus 0.970 times satisfaction plus, remember how we do the interaction tune? It's negative minus 0.443 times paid times satisfaction. Folks at home, can y'all hear me still?
Yep.
Thank you. Okay, we got this when satisfaction is 0 by doing what? I got some head nods.
So it's the intersect plus, 0.7151 times x1.
Yeah, exactly. This is the only one we're still worried about right now. That's how we got to this. When satisfaction is 0. Now I want to know what happens when satisfaction is high. How will I do that? I think it was 3. Let's look. Is this satisfaction or support? Oh, God. Overall satisfaction. Minimum is 1, max is 3. Oh, minimum is 1. Interesting. Interesting. Okay, so when satisfaction is high, then satisfaction equals 3. That was excellent deductive reasoning. Is that deductive reasoning? Excellent thinking to realize we needed to know that piece of information. How are we going to know? What math are we gonna do? Someone at home, make a guess. Giving you a very big hint.
Plug in 3.
Yeah, we're gonna plug in 3. Woo! We're gonna plug in 3. Now we can do some reduction to get there. And then what we'll know if we plug in 3, oh God, I have to do this math now. Let's do one for when, oh God, I'm gonna make you all do the math because I can't do it. For paid, if you're being, let's do one if you're not paid. Wait, which one is paid and which one's not paid? If you're paid, it's 0. So let's do one for paid. Come here.
So not paid is 1.
Correct. So if you're paid, this is the worst possible place to take notes in a syntax file. I'll share it with you when we're done though. So now we're going to reduce, this is just going to go all the way down to nothing because there's a 0. This is just going to go all the way down to nothing. So we end up with about, this is 3 and this is 1, so it's like 4.5-ish. Do I need to I can get a calculator. Should I get a calculator? Somebody in the room get a calculator and tell me what this should be.
2.919, but let me double check.
Are you for real?
3 times 0.970.
Plus 1.62.
Oh, I hadn't added that just yet.
Ah, okay. I was like, you just did all that in your head? Dang.
4.53.
4.53. This, my friends, is something called an estimated marginal mean. An estimated, because we just estimated it. Marginal, because it's only for part of it. Mean, because it's an average. So our estimated marginal mean for paid when satisfaction is high is 4.53. And now let's do it again for not paid. What's got to change to make it not paid?
Change those zeros to 1.
Changing those zeros to ones. Yep. Okay. Why, all of this has got to go. So now, my syntax is like, what are you doing? None of this is correct. It's not commands at all. I can reduce this because 3 times 1 is 3. I can reduce this because 0.751 times 1 is 0.751. You just did that math to get us 1.62 minus 0.751 plus. You did that math to give us 2.919, which is this times 3, minus, can someone do 0.443 times 3?
1.329.
Okay, let's keep going. Listen, I'm going to get it wrong. So we're going to get an Excel document. Okay? Equals. Whew. That's so much faster than trying to do it by hand. Y equals 2.45. The estimated marginal mean when you're not paid is 2.4. But, missed a step. That was not, I screwed up. I didn't screw up. I mean, that's correct. But what I wanted to actually show you is how this changes. This 0.970 times 3, this is our slope. Wait, that's not the slope I want. This is the slope I want, 0.751. That's the difference between paid and not paid. When you're paid, then our slope, the difference between paid and not paid, is 0.751. What am I trying to do? Oh, I was trying to look at the difference between the slopes when satisfaction is high and when satisfaction is low. So here it's 0.751. No, Jessica. Gracious goodness me. We're looking at the other slope. Here, the slope relating. Which slope am I looking at? I don't even know anymore. I don't remember my point. So let's just go back to this one, which is our expected score here. Y is 4.5, And here, when they're not paid, it's lower. And when satisfaction was 0, we didn't get this one all the way to, so let's do that. Paid. Paid, this will be 0. And so paid what will happen? This will become 0, and this will become 0, and so y equals no math necessary. And for not paid, now we'll have a 1. Whoops. For not paid, we'll have a 1 here, and we'll have a 1 here. But this one's still going to cancel out. This one's still going to cancel out. And we end up with this as our relation. Y equals 1.62 minus 0.75, which is just less than 1. Okay, so now we have our 4 points. Paid and not paid when satisfaction is 0, and paid and not paid when satisfaction is high. So that's one way we can get these, we can examine these. Let's do one other way, which is changing what 0 is. Okay, I'm going to bring forward the question we just did, which is this one. Oh, wait, what was our hypothesis? Were we right? At low levels of satisfaction, people not paid for research will have fewer publications than those who were paid to do research. Was that true? Let's look at the output. At low levels of satisfaction, which is satisfaction would be 0 would be a low level. At low levels of satisfaction, people not paid for research will have fewer publications than those who were paid to do research. That was our hypothesis. Do they have fewer? Yeah, you said it. Yes, they have fewer, but no, it's not significantly different from 0. Now to find higher, we looked at the difference. This looks like a difference to me, 2.4 versus 4.5. That's a pretty big difference, which means it's a little bit bigger. Both of those are going up. It's bigger. Both of these are bigger than both of these. And this gap is a little bit wider because we've let the interaction be in the model. But is it significantly different? We don't know. We have to recenter it to calculate it. So I'm going to do that. High satisfaction. I want to make it be high satisfaction, I want my 0 point to reflect high satisfaction. So I'm going to subtract 3 from the overall satisfaction score. So now anybody who has a 3 is going to be a 0. So my 0 point will reflect people with a high satisfaction rate. Centering was week 3, I think. We talked about that. Where we have, here, let me run it and then we'll look at it. Coral, what? What you mean?
Execute.
Oh, wrong program. Okay, so now it has run. What you mean? Ugh. So let's look at this. High satisfaction. See how the scores are 0, 0, 0, -1. So if it's -1, and all I did was take original scores and subtract 3, what was this score before? 2. Yeah, I can't do the math about these. There's some number with a decimal was here. 0, that means it was 3. If I find a -2, what would that have been? 1. Okay. So now I have that new variable. Now I'm going to run this guy with this new variable I just made called high satisfaction. I'm not changing anything else in my model. Everything else is the same. So now you'll see that the R squared is the same, hasn't changed at all. It's still 2%-ish. Here are my parameter estimates. Look at this number. This is different than it was before. The difference between, when satisfaction is high, it's the difference between being paid and not being paid to do research. Is 2 publications. That's this end of our graph. So look here, we have, this number is different. Remember before it was -0.7 something? And it was not significantly different from 0. But look at here. Now the 2 publications, that is significantly different from 0. We've moved around where we're interpreting this difference. So we're able to say there is a difference here. It's just at this high end. Look at this coefficient for high satisfaction. Did that one change? Let's remember it. Okay, there's the previous one. Look at that. Is it the same or is it different? One, two, three. There's 4 numbers that aren't 0 on here. 2 of them are the same, and 2 of them are different. Does it make sense that the number changed because we went from talking about right here to talking about from way up at the top of this scale? Down here, at the low end of satisfaction, the difference between our 2 groups is almost 0. It's not distinguishable from 0. But at the high end, it is distinguishable from 0. It's different. But we didn't change what the 0 point is here. So we're still interpreting the slope of the same line. So we're still interpreting the slope of being the paid one. That slope is still, for people who are paid, every 1 unit increase in our satisfaction score is an additional publication. We didn't move that 0. That 0 is the same. If we wanted to know about the relation between satisfaction and publications for people who aren't paid, we'd have to change that 0 point so that we could look at this other slope. Right now, we're interpreting this one because this one is what's 0. If we wanted to see the slope of this line, we'd have to switch what the 0 is. Okay, more things on this because I think we're going to actually stop here and we're going to pick it up next week and I will do the interaction that you suggested between our continuous variables. Oh, sorry folks, I couldn't see you. Okay, more things. Do you know how to run an interaction model within a GLM? Did you see how I did that? Susan will go over it again with you tomorrow. And do you... That was the big takeaway is knowing how to run an interaction, knowing why you would look for an interaction, and knowing how to interpret your output from an interaction model. So those are the 3 things. If you feel like you've taken that away, then we're in good shape today.